This is Mr. Nabi from Roger Bacon High School. This video is for AP Calculus on the chain rule. What I'd like you to do is to start with problem number 1 here, where you expand the following problems A through D. You can either use the binomial expansion theorem or you can do FOIL to expand these. But take about 3 minutes, 4 minutes here to pause the video and expand problems A through D. When you're finished, you may unpause and watch the rest of the video. So please pause at this time. All right, you should be back. Hopefully you've been able to expand all those. If you expanded them correctly, let me show you the answers. You should get 9x to the 4th plus 6x squared plus 1. For part B, you should get 9x squared minus 12x plus 4. For part C, you should get 20x squared plus 20x plus 5. And for the last set, x to the 3rd plus 9x squared plus 27x plus 27. Second thing I'd like us to do is to find the derivative of all these. Now there's no magic here, simply using the power rule. We get 36x to the 3rd plus 12x plus 0. We get 18x minus 12 plus 0. We get 40x plus 20 plus 0. And we get 3x squared plus 18x plus 27 plus 0. All right, on to question 2. Well, what type of functions are all A through D? Well, these functions, if I highlight them for you, are actually known as composite functions because you've got one function inside of another. So let's just look at f of x in problem A as an example. F of x is, well, we start out with squaring something. And what do we square? We square 3x squared plus 1. And I hope you can see this as two functions inside of each other. We're starting out with h of g of x. Well, h of x is simply something squared. That's what the outside function would be. And inside of the x squared function is g of x, which happens to be 3x squared plus 1. So this is known as a composite function. So in part A, h of x we said was the x squared function, g of x was the 3x squared plus 1 function. In part B, the h of x function is again a squared function, and inside that squared function is 3x minus 2. You might say to yourself, what are we squaring? Well, we're squaring 3x minus 2. In part C, h of x is actually 5x squared. And what are we squaring and then multiplying by 5? Well, that would be the g of x function, 2x plus 1. And lastly, h of x is the cubing function. And what are we cubing? We are cubing g of x, which is x plus 3. All right, we'll come back to this idea of composite functions after we learn about the chain rule. The chain rule is this. If you want to take the derivative of a composite function, all you have to do is take the derivative of the inside function and multiply it by the derivative of the outside function. In other words, we're doing g prime of x times f prime of g of x. So let's do an example here, and then we'll go back and do all the other examples from the other side. So f of x, let's just come up with an example here. Maybe it's 5x plus 4 to the 3rd power. All right, well, the inside function is the 5x plus 4, and the derivative of that would be 5. And the outside function would be the x cubed function, so that would be 3 times x squared. But keep in mind, it's a composite function, so this is not really x. It was 5x plus 4. That was what was inside. So this is our solution. And this could actually be simplified by squaring this term and then multiplying by 15. But I'll leave that for you. Let's go back up to the examples we have from earlier. Example A. Again, the inside function is 3x squared plus 1, so if I take the derivative of that, I get 6x. And then the derivative of the outside function is 2 times x, because the derivative of x squared is 2x. But remember that we actually had 3x squared plus 1 in there, So this is going to be our derivative. For the second example, the derivative of 3x minus 2, the inside function is 3. The derivative of the outside function would be 2 times whatever x is, but it was a composite function, so we plug in 3x minus 2 for this one. For part C, we do the inside function first. The derivative of 2x plus 1 is 2. And the derivative of the outside function, 5x squared, would actually be 10x. But again, keep in mind that x was actually 2x plus 1. And for the last one, the derivative of the inside is 1 times the derivative of the cubic function would be 3 times x squared. But again, we were squaring what was before a composite function, so x is actually x plus 3. Now I'm going to show you that these answers we get using the chain rule are the same as what we got when we expanded and then did the derivative. So if I were to simplify this problem, I would get, if I'd multiplied 12x by everything inside, I would get 36x cubed plus 12x. If I were to distribute this by 6, then I'd get 18x minus 12. If I were to distribute the 20 here to each of these terms, I'd get 40x plus 20. And if I were to actually FOIL this first term and then distribute the 3, let me do that piece by piece here. This FOILed out would be x squared plus 6x plus 9. And then if I distribute the 3, I get 3x squared plus 18x plus 27. And sure enough, this is the same as that, this is the same as that, this is the same here, and this is the same there. So you can either expand polynomials and then take the derivative, or you can use this chain rule to simplify the matter. And here are actually two examples where you need to use the chain rule because you can't change it any other way. You can't transform it into something you know how to take the derivative of. So let's look at example number 1. If I take the derivative, so dy dx, first of all, take the derivative of the inside, which would be 6x plus 2. And I want to multiply that by the derivative of the whole function, this whole function, which would be cosine, derivative of sine is cosine, of 3x squared plus 2x plus 1. Okay? So again, this is, if we were to think of this in terms of a composite function, f of g of x is sine of 3x squared plus 2x plus 1, and g of x is 3x squared plus 2x plus 1. I want to do g prime of x, which is here, times f prime of g of x, which is here. Example 2. Here we actually have 3 functions, 3 different functions all in one. And let me show you all the pieces. This is actually going to be, we'll call this f of h of g of x. But it's done the same way. The innermost function is 5x cubed plus 2x. So we'll take the derivative of it first. That's 15x squared plus 2. Now we work out. The next piece is sine of that. Well, that would be cos of 5x cubed plus 2x. And then the last piece is this cubing function. Well, the derivative of a cube is 3 times whatever squared. And this whatever, what was inside the cubing function, is sine of 5x to the third plus 2x. Plus 2x. Quantity squared. So this is the derivative. This is dy dx. All right, so this is kind of a more challenging problem, but the ideas are still the same. Derivative of the inside times the next layer times the next layer. In preparation for class tomorrow, I'd like you to try from page 158, problems 1 through 4, and bring your questions then.